dive. Today, we're really diving headfirst into some fundamental concepts in software development, stuff that often gets confusing, especially around Java. Our mission, using these great notes we've got, is to, unpack the real differences between programming languages, technologies, and frameworks. We want to cut through the jargon, give you a clear picture.
Exactly.
Whether you're deep in the field, prepping for something big, or just, curious, hopefully you'll get some practical insights today.
Absolutely. And it's more than just definitions, isn't it? It's about understanding why these things matter, how they connect, how they let you actually build things, seeing that bigger picture.
Okay, so building this digital world. Where do we start? The notes say right at the bottom, programming languages. They're called the raw materials, basic stuff for building applications. And this part's interesting. 10% ready-made, 90% user-defined, like raw ingredients.
That's a great way to put it, yeah. Raw materials. Think of them as the absolute bedrock. They define the syntaxes, the rules of how you write code, and the semantics, what that code actually means, its structure. They provide the tools, the compilers and interpreters, that turn our instructions into something the machine understands. And languages are used for everything. Operating systems, C for Linux, C++ for Windows, Java's big in Android, drivers, databases, all the tools we use. It all starts with a language.
So C++, Java, C#, JavaScript, Python, Ada too, apparently. Those are the core languages we're talking about.
Mm-hmm. And that brings us to a really interesting subset. JVM-based languages.
Oh, yes, the Java family.
Right. Java, Kotlin, Groovy, Scala. Even Ruby and Go sometimes get mentioned in this context. Now, each one has its own compiler, its own rules, its own feel, you could say. But the critical thing, after compilation, they all produce these .class files, bytecode. And this bytecode can run on one common platform, the Java Virtual Machine, the JVM.
Okay, so they all end up speaking the JVM's language, basically, which leads to this pretty bold statement in our notes. There is no need of learning other JVM-based languages, as Java is also JVM-based, and it is continuously growing.
That sounds quite strong. I mean, is there really no need to look at Kotlin or Scala if Java keeps evolving?
It's a provocative statement, definitely, and maybe a slight oversimplification, but there's a strong point behind it. Look, Java is incredibly resilient. It keeps adapting. Other JVM languages, like Kotlin, offers more conciseness, perhaps. Scala has powerful functional features. But Java hasn't stood still. Since Java 9, we get major updates every 6 months or so. And Oracle is actively pulling in good ideas from those other languages, functional programming concepts, for example.
So Java is kind of absorbing the competition's best features. In a way, yeah. The notes say Java roots are very deeper. Java branches are very wide. It's dominated for, 30 years. And the projection is it'll be dominant for another 25. So for most developers, most projects, investing deeply in Java, that's a really solid bet. It often means you don't have to learn Kotlin just to be productive, though knowing about them is never a bad thing, broadens the mind.
Right, specialization versus maybe spreading yourself too thin within that same ecosystem. Makes sense. Okay, let's move up a level from raw materials to software technologies. The notes call these semi-finished products, 30-40% ready-made, 60-70% user-defined. So more structure than a language.
Exactly. Technologies are basically specifications, sets of rules, guidelines, often delivered with APIs, libraries of pre-written code for specific jobs. But here's the kicker, the bit that often trips people up. Technologies themselves are not installable.
Not installable. Okay, hold on. If I can't install it, how do I actually use it? What does a developer do with it?
Yeah, that's the key. You don't work with the technology in the abstract. You work with technology-based implementation softwares.
Implementation software.
Right. These are the actual concrete programs or libraries that you do install or include in your project. They implement the rules defined by the technology. So working with that implementation software is working with the technology. It's like you learn to drive a specific car.
Right.
Not car technology.
Okay. The notes have some good analogies here, like a course browser versus the actual teacher, the faculty. The browser lists the topics, the rules, that's the technology, but you learn from the teacher delivering it, that's the implementation software.
Perfect analogy.
Or JDBC for databases.
Yeah.
JDBC is the technology, the rules for connecting. You don't install JDBC. You get a specific driver, like the Oracle one, OJDBC.jar, or one for MySQL. That driver is the implementation software.
Exactly. You work with the driver.
And same for servlets. Servlet technology defines the rules for web components. But you need something like Apache Tomcat, a servlet container, to actually run them. Tomcat is the implementation.
Precisely. And this whole model, this separation of specification and implementation, is a big part of why Java got so popular. Sun, and now Oracle, they define the technology specs.
Right.
But then lots of different companies, Oracle, third parties, open source projects can create the implementations.
So it creates a market? Options.
Exactly. You get choices. Commercial implementations, free ones. It makes the ecosystem really flexible, really open. Unlike some technologies where you're locked into one vendor, that openness was and is a huge plus for Java.
That makes a lot of sense. Flexibility is key. Okay, climbing higher still. Software frameworks, right? These are built on top of technologies, and they're described as fully finished products, like 80–90% ready-made.
Yeah, frameworks are all about accelerating development. They provide a huge amount of structure and pre-built functionality.
The examples given are Spring Boot, massive in the Java world, used for all sorts of applications, standalone, web, distributed systems, microservices.
And they are packed with features. The notes mention things like built-in, mailing facilities, batch processing facilities, scheduling facilities, security, single sign-on features, messaging. It's a lot of the common, complex stuff you'd otherwise have to build from scratch.
So they handle the boilerplate, letting developers focus more on the unique parts of their application.
That's the idea. They provide the skeleton, the infrastructure. The notes mention specific Spring modules too, like Core, AOP, Security, MVC, REST, Cloud. Each handles a different aspect, like basic dependency management, security concerns, web structure, building APIs, cloud integration. They really simplify building complex software.
Wow, okay. That progression language technology framework feels much clearer now. Raw materials, rules, then ready-made solutions. But let's shift gears a bit. What does all this mean for someone building a career? For their mindset? There's a really striking point in the notes. The product isn't the software you write. It's you becoming a Java subject expert. Your job title, your salary, those are just byproducts, like milk yielding buttermilk and cheese. What do you think of that framing?
I think it's a really insightful way to look at it, especially early on. The focus, particularly for freshers, has to be on that deep conceptual knowledge, getting the fundamentals right. The notes explicitly say, not mug up the abbreviations or just memorize definitions. Don't just parrot things back.
Right.
Develop your own interpretation of understanding. You need those analysis skills. Can you explain it simply? Can you connect it to other concepts? Understanding the why is always more powerful than just knowing the what.
And thinking about career paths, the notes mention starting as a Java dev, maybe aiming for full stack, perhaps even data science down the line. But there's some pretty direct advice about job changes early on.
Yes. It's quite provocative. It says, first 6 jobs you have to change for every 2 years. Then only your growth will be nice.
Every 2 years for the first 6 jobs?
Yeah.
It's frequent.
It is. But the thinking behind it isn't about being flaky. It's about maximizing growth. Early in your career, changing environments exposes you to different problems, different ways of working, new technologies, diverse teams. It pushes you to learn faster. And frankly, it often helps ensure your salary keeps up with your grading skills in the market. It's about avoiding getting stuck.
So strategic growth through controlled change rather than just job hopping.
Exactly. It's about being proactive about your learning curve and opportunities.
Okay, and one last piece on mindset, this quote about utilizing your time. If you utilize all 600 of day effective and build your career after joining company, you will get paid holidays to enjoy your life. What's the essence there?
It's about the payoff for focused effort, really. It's saying, put in the hard work, the effective work, early on to build those skills, that deep understanding. Invest in yourself, master your craft. If you do that, the 600 of the day might refer to being super productive in your working hours, perhaps.
Could be. Or maybe just generally being effective day in, day out.
Right. The point is, that initial dedication earns you significant freedom and reward later. Your skills become valuable, you work more efficiently, maybe command better roles, better pay, which translates into more resources and flexibility to actually enjoy life, including those paid holidays. It's the long game. Focus now, benefit later.
What a journey today. We've gone from the raw materials of languages through the rules and specs of technologies, right up to the ready-made structures of frameworks. It feels like we've built a much clearer mental model of how these pieces fit together.
Absolutely. And hopefully everyone listening sees that this isn't just, academic. It's not just for passing an interview. Understanding these fundamentals, really understanding them, is what lets you adapt. Because the tools will change. New languages, new frameworks, they pop up all the time.
That's the only constant, right?
Change. Exactly. But if you grasp the underlying patterns, the role of a language versus a technology versus a framework, you could pick up new things much faster. You see how they fit into the bigger picture. That adaptability, grounded in solid fundamentals, that's your real superpower in this field. It's what allows you to keep growing and contributing no matter what comes next.